This tutorial will show how SAFE can calculate dynamic periods and mode shapes. In this example, we wish to extract the vertical dynamic properties of a 1 bay by 1 bay suspended slab. The slab is 10 inches thick with planned dimensions of 10 feet by 10 feet. The slab supports a piece of industrial equipment that weighs 20,000 pounds. We will use the weight of the equipment plus the self-weight of the structure to determine the modal mass. We will create this model using the two-way slab template. We will set the units to kip feet. Each direction will have one span with a 10-foot spacing. The slab thickness is 10 inches, and we will set the additional dead load equal to 0, as we will add the equipment load separately. We will switch off the dimension lines and horizon. We will zoom in so that we may see our model better, and then go to the Define Load Patterns command. In addition to the dead and live load patterns, and note that the dead case has a self-weight multiplier of 1, we will add a pattern for the equipment load. Next, select the slab object and go to the Assign Surface Loads command. Here, we will assign the equipment load using pounds per square feet with a load of 200 pounds per square foot in the gravity direction. This load is 20,000 pounds divided by the area of the slab. Next, we will define the mass source. This tells the program which load patterns to use to calculate the mass. In addition to the dead load, which is the structure's self-weight, we will add the equipment load pattern. The program will combine these loads, and the resulting net load in the down direction will be divided by gravity to determine the mass. The scale factor here only tells the program how to combine the loads. It should not include gravity. Leave the Ignore Lateral Mass option checked, as we want modes only in the vertical Z direction. Next, we will define the load cases. In addition to the dead, live, and equip load cases, we will add a new case for modal. When we select modal for the load case type, we can then choose either eigenvectors or Ritz vectors. We will select eigen and ask for 12 modes. Now we are ready to run the analysis. After the analysis is complete, we will shut off the grids and switch to a 3D view. We will zoom in to enlarge the view. Next, we will go to the Deform Shape display and ask for the first mode shape. This shows that the first mode has a period of 0.032 seconds, or a frequency of approximately 31 Hertz. Just like any other deformed shape, we can animate the mode shapes. If we click on the VCR buttons, we can switch modes. Modal information is also available through the Display Show Tables command. Under the Structure Result Data, select the Modal Information option. A table is created that displays the periods and frequencies of all the modes. This concludes this tutorial.